Okay, the last step of using the Lagrangian method is to solve the system, just like for a firm's problem. We're going to solve the system of equations. Okay, so notice that we have a partial derivative with respect to every choice variable. So in this case, we had two choices, the amount of food and shelter, and so we have two equations there. And then we have a third equation with the Lagrange multiplier. So we have a third equation, and the Lagrange multiplier is also a variable. It's endogenous. We don't know what it is. And so we end up having three equations and three unknowns. But what's really going on is that we have kind of two equations we care about, the first two, and then we have a third condition, which is the budget constraint. Okay, so this is what's kind of neat here. Let's zero in just on these guys here. And notice that we set them all equal to 0, and in the last video I said this implies the marginal utility of food is equal to lambda times PF, and the marginal utility of shelter is equal to lambda times PS. And also, the fact that this last first order condition is equal to 0 spits back out the budget constraint. We need y to equal PF times F plus PS times S. Let's combine these two equations by dividing one side by the other. Okay, so we're going to divide MUF by MUS. MUF is equal to lambda times PF. MUS, if we divide both sides by MUS, it wouldn't be very interesting, but we know MUS is also equal to lambda times PS. And we get this. These cancel out, and we have PF over PS. And this here is equal to the negative marginal rate of substitution when we do the partial derivative of S with respect to F. Okay? What we've done here is we've said the marginal rate of substitution is equal to the price ratio. And so we can see that the Lagrangian method has actually delivered us back to the same point that we got to graphically, okay, where we have now two equations and two unknowns because we've eliminated this lambda by combining some of the equations, and we're now down one equation, but we're also down one unknown because we don't actually really care about that Lagrange multiplier. It's just a tool we use to get us to the answer. And so we could solve this system the same as before. So why is this any better than the using that graphical argument? Well, because as we'll see in the next video, the Lagrangian method is like a general purpose tool that you can use for lots and lots of different types of problems. Okay.